In the last video, we looked at how global temperatures have changed in the modern era, as shown by temperature recordings. To better understand recent temperature changes, though, we need to look further back in time to provide some context. The Earth is about 4.6 billion years old. Over this time, global temperature has obviously fluctuated heavily. During the first few hundred million years of Earth's history, the Earth was regularly bombarded by asteroids and comets. Much of the Earth's surface was covered with molten rock, which only gradually began to cool and solidify to form continents. Temperatures were initially extremely hot, but then cooled off. Still though, they remained much higher than they are today, or likely at any other time. In the early years, ocean temperatures may have been as hot as 185 degrees Fahrenheit or 85 degrees Celsius before gradually cooling off more over the next several billion years. Around 2.4 billion years ago, major global changes were in motion. Oxygen, produced by photosynthetic bacteria, began to accumulate in the atmosphere for the first time. Possibly as a result of this atmospheric change, or because of other factors, Earth's temperature began to fall. This was the start of Earth's first known ice age. Ice came to cover large portions of the Earth's surface. This ice age was the start of a period of colder temperatures that lasted for several hundred million years before temperatures began to increase. After another several hundred million years of warmer temperatures, another period of colder temperatures began, lasting from around 720 million years ago to 635 million years ago. This period included two major ice ages. The further back in time we go, the more uncertainty there is. Much is not known about many of the details of these early years of Earth's temperature history. We have a somewhat better idea of past temperatures beginning around 500 million years ago, or about 4 billion years after the Earth was formed. Researchers have developed a number of approaches for estimating past temperatures using information that has been preserved in the geologic record. This is done by analyzing the ratios of different isotopes and elements that are present in the ancient fossils of organisms that used them in their biological processes. In particular, the ratio of oxygen-18 to oxygen-16 in the shells of ancient animals is one of the most important measurements. Studies using these tools have shown that temperatures over the past 500 million years have fluctuated significantly. Some periods were as much as 25 degrees Celsius warmer or colder than others. Major ice ages began around 450 million years ago and around 350 million years ago. At the start of this period, 500 million years ago, life on Earth was very different. The Cambrian explosion, which started around 540 million years ago, began a period of rapid diversification and expansion of species. Nearly all animals alive today trace their origins to the Cambrian period. Initially, life on land was very limited. This began to gradually change as plants and animals began to colonize the land following the Cambrian explosion. Life on land then came to rapidly diversify into countless different species. Dinosaurs eventually evolved and became a prominent form of life from around 245 million years ago up to 66 million years ago. This graph shows temperature change over this very long period of time. This, however, doesn't even bring us close to a timescale relevant to humanity. That requires a narrower timescale. Looking at temperatures over just the past 66 million years, we see that initially, following the impact of the asteroid that led to the extinction of the dinosaurs, temperatures were considerably warmer. At around 35 million years ago, temperatures declined and the Earth entered another ice age. There came to be permanent ice sheets, or glaciation, over Antarctica. Temperatures then declined even further, and around 2.5 million years ago, there came to be permanent glaciation in the northern hemisphere, including permanent sea ice over the North Pole. This graph, though, still barely shows the onset of human life. With the beginning of permanent ice at both the North and South Poles, the climate developed into a repeating cycle of rising and falling temperatures. As the Earth cooled, ice sheets would expand and spread further toward the equator. These are known as glacial periods. As the Earth warmed, global ice cover would retract. These are known as interglacial periods. These repeating glacial cycles that have defined Earth's climate since around 2.5 million years ago are primarily driven by solar orbital effects along with a variety of feedback mechanisms. These are long-term forces that have an impact on the scale of tens of thousands to 100,000 years. The Earth has been through many of these cycles over the past 2.5 million years. The ice that has been deposited over this time has served as an important source of information about the past. By drilling holes into the ice and withdrawing ice cores that can be analyzed, researchers have been able to gather useful data. Ice cores are a key source of information about past temperatures and atmospheric conditions for up to around the past 800,000 years. Modern humans only emerged around 300,000 years ago. Human civilization is only around 10,000 years old. We are currently in a warmer interglacial period. The last glacial period peaked around 20,000 years ago, after which temperatures began to warm. Emerging from this colder period, humans began to develop agriculture for the first time around 12,000 years ago. This was followed gradually by the development of human civilization. Over the past 10,000 years, global temperatures have remained relatively stable. There has, though, been some fluctuation, particularly a slight cooling trend over the past 5,000 years. For more recent time periods, stretching back for several hundred up to several thousand years, tree ring data becomes another important source of information. The size of annual tree rings varies based on climate factors, including temperature. By finding many samples of ancient preserved wood and comparing what years their tree rings overlapped, researchers have been able to create long-term temperature records. This tree ring data provides an additional perspective into historical temperatures. Studies using tree ring and other data sources show how temperatures have changed over the past 2,000 years. Temperatures declined somewhat between the years 1200 and 1800, but have over the past 200 years started to sharply increase. This increase is especially clear when looking at data from modern temperature recordings, as we covered in the previous video. One important thing that should be taken away from looking at this data about temperature changes over Earth's history is the many different timescales over which change takes place. 450,000 years ago, the temperature was around 5 degrees lower than it is today. It then rose to a temperature closer to today's temperature by around 420,000 years ago. This change took place over about 30,000 years. Similarly, around 380 million years ago, temperatures were significantly warmer, but they then declined by over 15 degrees by 340 million years ago. This change took place over a time span of about 40 million years. This highlights a very important fact, which is that there are many different factors that drive global temperature change, and they often have an effect on very different timescales. Most of these factors have an impact over long timescales, from tens of thousands of years to tens of millions of years. Some factors, though, can cause more rapid spikes or dips in temperature. Moments where this has happened have been recorded at various times in the temperature record. Another important thing to consider is that while the Earth has been through many dramatic changes in temperature, humanity and human civilization are quite new and have experienced relatively little change in global temperature. Especially over the past 10,000 years that human civilization has flourished, there has been very little change. It's important to keep this in mind when considering what potential changes in the global climate could mean. The onset of human civilization also represents something profoundly new in the history of the Earth. The incredible technological advancements that humans have achieved and the massive scale of human infrastructure and settlement are completely unprecedented. The effect of this is that it potentially introduces new factors that could drive changes in global temperature. As we have seen, temperatures over the past 200 years have been rapidly increasing. But to truly understand this change, we have to examine the ways in which humanity and the global climate system interact, and in particular, if there are any human activities that could adequately explain this recent rise in temperature. That is what we will focus on in the next video.